Welcome to ANMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Exercise 8.7. Number 1. A particle moves along a straight line and passes through a fixed point O with an initial velocity of 3 meters per second. Its acceleration a meter per second square, t seconds after passing through O is given by a equals to 6 minus 3t. Find the instantaneous displacement in meter of the particle when t equals to 5. So from the information we know, V0 is 3 meters per second as the initial velocity is 3 meters per second. And the function of acceleration given is 6 minus 3t. We need to get the displacement. So first we need to get the velocity by integrating the 6 minus 3t, which is the function a. And we get v equals to 6t minus 3t squared over 2 plus c. Then when v equals to 0, our initial velocity equals to 3. Therefore, 3 equals to 0 minus 0 plus c. So c equals to 3. So the full function of velocity will be v equals to 6t minus 3 over 2t squared plus 3. And we need to find the displacement function. Therefore, we integrate the function of velocity again with respect to t. So we get 3t squared minus 1 over 2t cubed plus 3t plus c. And when the t equals to 0, the particle is at the fixed point O. So s equals to 0. Therefore, we will get c equals to 0. Hence, the s is only 3t squared minus 1 over 2t cubed plus 3t. So now, we can find the instantaneous displacement. When t equals to 5, the s will be 3 times of 5 squared minus 1 over 2 times of 5 cubed plus 3 times of 5, which we get 27.5 meter. Then b, its velocity is uniform. So when the velocity is uniform, means that the dv dt is 0 or the acceleration is 0. So acceleration equals to 0 happen when t equals to 2. So when t equals to 2, we need to find the instantaneous displacement. So the s will be 3 times of 2 square minus half times of 2 cube plus 3 times of 2. And we get 14 meter. Question number 2. Acceleration a meter per second square for a particle moving along a straight line t seconds after passing through a fixed point O is given by a equals to 12t minus 8. Given the velocity of the particle t equals to 1 second after passing through O is negative 10 meter per second. Find the instantaneous displacement of the particle when its acceleration is 4 meter per second. So we are given the a is 12t minus 8. So from the function of acceleration, we can get the function of velocity by integrating the 12t minus 8. We get v equals to 6t squared minus 8t plus c. And when t equals to 1, we are given that v equals to negative 10. So sub in the negative 10 and 1, we get c equals to negative 8. So the full function of velocity is v equals to 6t squared minus 8t minus 8. We need the displacement function so that we can find the instantaneous displacement. Therefore, we integrate the v again with respect to t. So the s equals to 2t cubed minus 4t squared minus 8t plus c. So when t equals to 0, the particle is at the fixed point O. Therefore, s equals to 0. Hence, c will be equals to 0. So the function of displacement is s equals to 2t cubed minus 4t squared minus 8t. So now, we need to find the instantaneous displacement when the acceleration is 4 meters per second. We need to know when is the time that we have acceleration 4 meters per second squared. So when a equals to 4, the 12t minus 8 equals to 4, it happens when t equals to 1. Then we need to find the instantaneous displacement when t equals to 1. So we sub t equals to 1 into the function of displacement. we get s equals to 2 times of 1 cube minus 4 times of 1 square and minus 8 times of 1. We get s equals to negative 10 meter. B, when the particle is at rest. So when the particle is at rest, basically the velocity is 0. So when v equals to 0, we can use the function of v, 6t squared minus 8t minus 8 equals to 0. And we can factorize out 2 from the 6t squared minus 8t minus 8 equals to 0. So we get 2 times of 3t squared minus 4t minus 4 equals to 0. Then we can still factorize this quadratic expression. So we get 2 times of 3t plus 2 and t minus 2 equals to 0. We get 3t plus 2 equals to 0. We get a negative values of t, which is negative 2 over 3. We can ignore the answer because t is always positive. Okay, we are talking about time. So we only use t equals to 2. So when t equals to 2, the instantaneous displacement will be 2 times of 2 cubed minus 4 times of 2 square minus 8 times of 2. And we get s equals to negative 16 meter. Question number 3. So question number 3. A particle moves along a straight line and passes through a fixed point O with an initial velocity of 8 meter per second. The acceleration a meter per second square at the t seconds after passing through O is given by a equals to 10 minus 60. Find a, the maximum displacement of the particle. So from the acceleration, we need to find displacement. So first, we'll get the v by integrating 10 minus 60. So we get 10t minus 3t squared with the initial velocity of 8, so we plus 8. And then from here, we get the displacement function by integrating the 10t minus 3t squared plus 8. We get s equals to 5t squared minus t cubed plus 8t. And you will see the c equals to 0 because when t equals to 0, displacement, the particle is at the point O, so the s equals to 0. Therefore, c also equals to 0. So this is only the function of displacement. So come back to A. We need to find the maximum displacement of the particle. So maximum displacement happen when the v equals to 0 or the ds dt equals to 0. So when v equals to 0, 10t minus 3t squared plus 8 equals to 0. Arrange it so that we have a general form of 3t squared minus 10t minus 8 equals to 0. And by factorization, we will get 3t plus 2 and t minus 4 equals to 0. So end up, t is equals to 4 when the maximum displacement happen. And what is the displacement? We need to substitute the 4 into our displacement function. So maximum displacement equals to 5 times of 4 squared minus 4 cubed plus 8 times of 4, which is 48 meter. B, the distance traveled by the particle in the 5th seconds. So if we want the 5th seconds, means we want the distance traveled by the particle from the 4th second to the 5th second. Alright, so we will see when t equals to 0, t equals to 1, 2, 3, 4 and 5. This is about t, okay. Then this is first second, second, third, fourth and fifth, right? So I want the displacement, okay, we are actually talking about the difference of displacement of S5 and S4. Therefore, we can use integration, okay, of the velocity function from 4 to 5. Alright, and by integrating it, alright, we will get negative 8. So, means that we are travel toward left 8 meter. So distance is always positive, alright? It's a scalar quantity. So distance traveled is 8 meter. Alright? So from t equals to 4 until t equals to 5, we are moving to the left 8 meter. So the distance traveled is 8 meter. Question number 4. Farhan participates in a cycling event organized by a cycling society. Farhan is cycling along the straight road at t hours after passing the straight point. Its acceleration a km per hour is given by a equals to 4t minus 16. And his starting velocity is 30 km per hour. A. Express the acceleration function and the velocity function in terms of t. I believe, okay, we need some correction, okay, about acceleration function since this is given. Alright, so we change the question into express the displacement function and the velocity function, okay, in terms of t. Alright, therefore the S is here. Okay. So from the A given 4t minus 16, we will get V equals to the integration of 4t minus 16 dt. So we get 2t squared minus 16t and the initial velocity of 30 km per hour. Okay, therefore we plus 30. So again, we integral the V so that we can get the S, the displacement function. So by integrating 2t squared, we'll get 2 over 3t cubed. Integral the negative 16t, we'll get negative 8t squared. And integrating positive 30, we get positive 30t. Okay, plus C will be 0 because the particle is at the fixed point O, okay, or at the fixed point O, okay, when the t equals to 0. Okay, so the S equals to 2 over 3t cubed minus 8t squared plus 30t. Right? B. Prove that Farhan stopped instantaneously when t equals to 3. So stop instantaneously means that I'm not moving. I should have no velocity. Alright, so the V equals to 0. Okay, so 2t squared minus 16t plus 30 equals to 0, and we factorize out the 2, we get 2 times of t squared minus 8t plus 15 equals to 0. So factorize the t squared minus 8t plus 15 again. So we get 2 times of t minus 3 and t minus 5 equals to 0. So we will get t equals to 3 and t equals to 5. Alright, so we can show that Farhan stopped instantaneously at t equals to 3, and the unit here should be in hour. Alright. C. Find the total distance traveled in km by Farhan in the first 3 hours. This is in km. Alright. So we see from the first 3 hours, Farhan doesn't change direction. He doesn't stop, right? Because when he stopped only, t equals to 3. So we can straight away integral from 0 to 3 of the velocity function. Okay, so 2t cubed minus 8t squared plus 30t from 0 to 3. So sub in the 3 minus the 0. Then we get 36 km. Thank you.